everyone. This is Group 7 video presentation. This topic is titled The Parts of Problem Solving and Reasoning with a theme of logical reasoning and converse statement. And these are group objectives. This will help all students by increasing knowledge so that they can use it to accomplish any task that is consistent with the use of problem solving and reasoning. The second one, to influence and share with other students about the use of problem solving and reasoning as well as the use of if-then statement and converses. Third, so that it can be remembered or memorized by all students towards the work process by using problem solving and reasoning, including its part which are called statement and converses. Before we will start, I will show first the contents, parts, and flows and the video presentation called the Group Conceptual Framework. Now, we will proceed the introductions. Problem solving and reasoning expand students' knowledge. These discussions provides information to students to fully understand the content and discussions that are consistent with ability, knowledge, skills, and logical methods. Besides, the reasoning can take the form of deductive inference, whereby the evidence guarantees the truth of the conclusions. This means that it also helps all students, especially in the research part. In this study or discussion, it is necessary for all students to be able to learn and discuss the methods of solutions and problems to be solved in order to focus on gathered information refers to as mathematics and the modern world.
Good day everyone, my name is Jeffrey John Ukilian. I will be discussing the problem solving. Problem solving is the process of achieving a goal by overcoming obstacles, a frequent part of most activities. Problems in need of solution range from simple personal tasks to complex issues in business and technical fields. Reasoning. In mathematics, reasoning involves drawing logical conclusions based on evidence or stated assumptions. Sense in making may be considered as developing understanding of a situation, context, or concept by connecting it with existing knowledge or previous experience. The four types of reasoning will be deductive reasoning, inductive reasoning, abductive reasoning, and reasoning by analogy. Conjecture. A conjecture is a mathematical statement that has not been yet rigorously proved. Conjecture arises when one notices a pattern that holds true for many cases. However, just because a pattern holds true for many cases does not mean that the pattern will hold true for all cases.
Now we will discuss the intuition and analogy. What is intuition? Intuition is ability of gaining direct knowledge or cognition without evidence, rational thought, and power that makes it possible to know something without any proof or evidence. Example, number 1. What would be the product of 378 plus 113 divided by 2? The answer would be around 200 plus. That would be not the exact answer, but it is somehow accurate and mostly right. Number 2. They say that when you feel something is wrong, you should trust your intuition. What is analogy? The analogy is a comparison of two things to show their similarities or relationship, typically for purpose of explanation and clarification. Example, hungry is to eat, as thirsty is to drink. Tree is to live, as flower is to petal.
Inductive reasoning is the act of using specific scenarios and making generalized conclusions from them, also referred to as cause and effect reasoning. Usually through observation and measurement and then making a conjecture based on the gathered information. For example, you might observe that your older sister is TD, your friend's older sister is TD, and your mother's older sister is TD. Inductive reasoning would say that therefore, all older sisters are TD. Another example, find the sum. 1 equals 1, 1 plus 3 equals 4, 1 plus 3 plus 5 equals 9, 1 plus 3 plus 5 plus 7 equals 16. 1 plus 3 plus 5 plus 9 equals 1 plus 3 plus 5 continuous. 2n minus 1 equals n numbers. So the solution is 1 plus 5 plus 7 plus 4 to the power of 2 equals 16. 4 odd numbers, 5 odd numbers. From these notes, we can make this conjecture. Sum of the first n odd numbers is n to the power of 2 or 1 plus 3 plus 5 plus continuous n minus 1 equals n to the power of 2. Deductive reasoning is a process of showing that certain statements follow logically from agreed upon assumption and proven facts. For example, consider the statements all apples are fruits when you introduce specific piece of information like all fruits grow on trees. You can then deduct all the apples grow on trees. Another example given: 3x minus 8 plus 5 equals x minus 5. Apply distributive property. 2x minus 32 plus 5 equals x minus 5. Combine similar terms. 12x minus 27 equals x minus 5. Apply subtraction property of equality. 11x minus 26 equals negative 5. Apply addition property of equality. X equals 2. Use division properly of equality. Another example. Suppose that the given statement is true. Use deductive reasoning to give another statement that must be also true. All birds can fly. Tweety is a bird. Solution: Tweety can fly.
In mathematics, you will come across many if-then statements. For example, if you go outside without sunscreen, then you get a sunburn. Therefore, this is a conditional statement because it confirmed the under certain conditions, like going outside without sunscreen, is something happen and that you get a sunburn. A conditional statement is a statement with a hypothesis followed by a conclusion. The hypothesis states that the given facts are assumed as true, and it is in the first or if part of a conditional statement. The conclusion states what needs to be proven, and it is in the second or then part of a conditional statement. The conclusion is the result of a hypothesis. Based on the example given earlier, if you go outside without sunscreen is the hypothesis, then you get sunburn is the conclusion.
Good day, this is Mark John Room and I am here to tackle about the converse statement and the biconditional statement. But first, let me talk about the converse statement. What is a converse statement? A converse statement is a statement obtained by reversing the hypothesis and conclusion of a conditional statement. For example, if Hannah is thirsty, then she drinks water. It's a condition. The converse statement is, if Hannah drinks water, then she is thirsty. Now let me talk about the biconditional statement. What is biconditional statement? A biconditional statement is a combination of conditional statement and its converse written in the if and only if form. For example, state the converse of the given conditionals. If two segments are congruent, then they have equal lengths. Solution: if two segments have equal lengths, then they are congruent. Example number 2. A line is a bisector of a segment if it intersects the segment at its midpoint. Solution: conditional. If a line is a bisector of a segment, then it intersects the segment at its midpoint. Converse: if a line intersects a segment at its midpoint, then the line is a bisector of the segment. That will be all, and thank you.